if you see what is kind of cool about those numbers, let me see hands, let me see hands. Good, this is good, this is very, very good. This is very, very good. There is something extraordinarily neat about these values of numbers. Sydney, let me hear what it is.
They average up to 0, they all add up.
If you add up those 6 percentages, what do they add up to?
No way.
Check it out. Check it out.
Way.
0.12.
Way.
0.12 plus negative 0.32. That's a negative 0.2 right there. Now we're at negative 0.2. Negative 0.2 minus 0.08, negative 0.28. Negative 0.28 plus 1, negative 0.27. Negative 0.27 plus 0.16, negative 0.11. Negative 0.11 plus 0.11, 0.
Negative as well.
So the negatives cancel the positives, if you will. You've got two negatives, which add up to negative 0.4, 40%. So in other words, these two were a combined total of 40% off. But these were a combined total of 40% too much. Is that coincidental?
No.
Is that coincidental? I vote for no. Is it coincidental that those percentages add to 0? I have one vote for no. A very, very strong vote. No.
Yeah,
Very
there's
quick.
nothing coinky-dink about.
Why is there nothing? She's correct. Lynn's correct. There is nothing coincidental. That is not a coincidence that they add to 0. That is not a coincidence. Why is it not a coincidence? Why is that not a coincidence?
Because the statistics.
Where is the math that says it has to add to 0, though? I agree that math is adding and dividing and things like that, but why? Who says that it has to add to 0?
Because
Help me out, Jake.
So wait, there's so many roles. There's so many roles that you have.
How many?
There's 320 roles, and you have to equal 0 within.
Here's why. Check this out, friends. When we added up this and this and this and this and this and this, essentially what we did was we added up this fraction, this fraction, this fraction, this fraction, this fraction, and this fraction. That's what we did, except we didn't add the fractions, you had the decimals, right? Okay, now, but they started from the fractions. Let's think about that. Let's think about these fractions right here. When you add fractions, you add the numerators and you keep the denominators the same. So in order for all these to add to 0, let's ignore the denominator, because the denominator can't be 0. Let's just look at the numerator. Fair? Numerator. 60 plus 36 plus 49 plus 54 plus 62 plus 59 has to add up to 320. Ready so far? That has to be 320 because if you rolled 320 times, we broke it up into how many 1s, how many 2s, how many 3s, how many 4s, and 5s and 6s we got. Fair enough? Okay. 53.3 plus 53.3 plus 53.3 plus 53.3 plus 53.3 plus 53.3 is not easy to say, but what does it add up to? Say it. 320. It has to. Mostly because we said 1/6 of 320 is 53.3, so adding it 6 times gets you back to 320. So essentially, when you add them all together, you're adding 320 and then subtracting 320, which 0 is that? It has to equal 0. So there's no coincidence there. That has to sum to 0. The amount that you're off up has to be the amount that you're off down. This is the definition of what an average is. Check this out. Check this out. I did a quick little graph while you guys were taking your break. This is badass. This is what Americans don't understand. Americans don't understand what an average is. Americans do not understand what an average is. This will hopefully give you a graphic to show you why.
Sean, when you're doing it though, it's going to be a little bit less because of rounding.
Well, yes, the 53.3 is actually 53.3 repeated.
Yeah.
Yes, but if you ignore the rounding,
So
it's equal.
Statistics, there could be like a 1%.
Yes, it's called non-sampling error. We'll talk about it in 244. Friends, in red, your results. In red, your results. Notice how some are taller than others. Some are taller than others. The taller ones, the 1s, the 5s, we got too many of those, correct? We got 61s, we got 62 5s, too many, 59 6s. The ones that are below the blue line are the ones we had too few of, the 49, the 36. The blue line across the top there represents the 53.3, the 53.3. Tell me about, Matt, what are you seeing?
I'm seeing that the remainders above the blue line, if you add to the other ones and distribute them, you'll get equally all the way across.
Boom! That is the definition of what an average is. You take across the top, take the parts of the line across the top that are too big, and they fit if you stack them on the short ones and bring the short ones up to the blue line and bring the top ones down the blue line. That's what an average is.
Pips.
That's what an average is. An average is a sharing. That's what it is. That's exactly what 53.3 represents. If we did 320 rolls and got exactly the same 1s, 2s, 3s, 4s, 5s, and 6s, it would look like that blue line. That's the difference. That's the difference. Fair enough? That's why that percent error has to sum to 0, because these guys are just as much above the line as they are below the line. Cool?
I have a question.
Go ahead, Kurt.
If we were to say just do this all over again, erase everything and start over.
We're going to in a minute. So that's the point. Is I want to do this again, but I don't want to start all over again. I want to build on this.
Okay, is it still going to be 53.3?
Let's find out.
Okay.
Let's find out. Let's repeat the experiment, but this time I want you to each spin 20 times. This time I want you to each spin 20 times. I want to get more data, and we're going to add the new data to this. And I want you to predict what's going to happen overall. We're going to do the exact same chart we'll do on that side next time. Maddie, go ahead.
What if you pips?
Oh, pips is the dots. They're called pips.
Oh, okay.
So you got 1 pip, 2 pips, 3 pips. It's a silly little word.